Welcome to General Aviation Weather Planning, KDTL to KGPZ, Preflight Weather Product Interpretation. This module is a product of research conducted under FAA's Weather Technology in the Cockpit program. It is not meant to replace flight instruction. For more information, please contact a flight instructor in your area. Reminder: continuing VFR flight into instrument meteorological conditions is illegal and dangerous. Use caution when approaching areas of reduced visibility and precipitation. Introduction. The purpose of this course is to assist pilots in interpreting and applying information from common weather products to their pre-flight weather brief. As you proceed through this course, you will encounter interpretation questions. Write down the answer to these questions as you go. They will be used at the end of the course for the overall assessment. This course will be broken up into 4 primary sections. First, we will go over the flight scenario. Then, we will look at weather product interpretation. Weather products will be organized into 3 groups based on the nature of the information. Big picture products will give pilots a general sense of the overall weather. Hazards show pilots weather that might pose a risk of instrument meteorological conditions. Finally, we will illustrate the products that show visibility. Once all the weather product sections are complete, we'll move on to the flight implication section, where we'll discuss how the weather is trending, the hazards we might expect to encounter for this flight, and what potential solutions we have for mitigating the risks of this flight. Now let's begin by looking at the flight scenario. For this course, you will be planning a direct flight from Detroit Lakes Airport, Wheating Field in Detroit Lakes, Minnesota, KDTL, to Grand Rapids Issaquah County Airport in Grand Rapids, Minnesota, KGPZ. This flight is based on historical data from May 24, 2017. The time of your pre-flight will be at 2300 Zulu, which is 6 p.m. local, and your departure time will be 0000 Zulu, or 7 p.m. local. At KDTL, the time zone is UTC-5 during daylight savings time. The variation at the airfield is 5 degrees east. The airport field elevation is 1,397 feet mean sea level, and the pattern altitude is 2,197 feet mean sea level. At KGPZ, the time zone is UTC-5 during daylight savings time. The variation at the airfield is 0 degrees east. The airport field elevation is 1,298 feet mean sea level, and the pattern altitude is 2,001 foot mean sea level. The flight will be conducted in a Cessna 172S Skyhawk. The aircraft will be outfitted with a G1000 navigation system. For weight and balance purposes, you can assume there is one pilot weighing 150 pounds, and the aircraft has 53 gallons of fuel. The empty weight of the aircraft is 1,600 pounds, and the max takeoff weight is 2,550 pounds. Before you begin to look at weather products, it is important to refresh yourself on your personal minimums for weather. Your personal minimums should be at or above the FAA required minimums. They should reflect the minimum weather conditions required for you to be comfortable with the flight. They should be based on your pilot certification, experience, proficiency, and currency. For reference, the FAA recommended personal minimums are listed. Now on to weather product interpretation. First, we will look at big picture weather products. Big picture weather products include the low-level significant weather chart, surface analysis, surface prognostic, satellite, and radar. We will begin with low-level significant weather chart. The low-level significant weather chart is issued every 6 hours: 0 Zulu, 6 Zulu, 12 Zulu, and 18 Zulu. The low-level significant weather chart provides a 12 and 24-hour forecast. The valid times for this product can be found in the bottom left corner of each box. This product is important because it provides the pilot with forecast information on moderate and severe turbulence, widespread instrument flight rule conditions, widespread marginal visual flight rule conditions, as well as notifies pilots of whether the freezing level is above or under the planned flight level. When you look at this chart, you will notice regions enclosed by borders of different colors. Each color represents a different weather condition. Red circled areas on the chart indicate regions where IFR conditions are present. Blue scalloped areas on the chart indicate regions where MVFR conditions are present. Yellow dashed areas indicate that moderate or greater turbulence is present. Finally, light blue lines indicate freezing levels. If the light blue line is solid jagged, the freezing level is at the surface. If the line is dashed, it is indicating the freezing level height is above mean sea level. Quick tip: this product is a forecast product that projects 12 and 24 hours into the future. This makes it a good product to check the day before your flight to gain a better understanding of how the weather may develop. This is, however, still only a forecast of what might happen, and accuracy typically degrades between the 12 and 24-hour forecasts, so it is important to check other weather products the day of your flight. This brings us to our first set of interpretation questions. Please read through the questions and write down your answer. Let's go over the answers. Question 1. Do you have any red areas of IFR activity along your flight route? The answer is no. There are no red IFR areas. Question 2. Do you have any orange areas of turbulence along your flight route? The answer is no. Question 3. Do you have any blue areas of MVFR activity along your flight route? The answer is yes. There are some blue areas of MVFR activity. Question 4. What is the freezing level for your flight route? The answer is 8,000 feet. And question 5, are you flying above the freezing level? The answer is no. Now let's move on to surface analysis. The surface analysis is issued every 3 hours and displays fronts and pressure systems. Low pressure systems, denoted by a red letter L, are commonly associated with clouds, precipitation, and unsettled weather. High pressure systems, denoted by a blue letter H, are commonly associated with fair weather conditions. However, they may also be associated with nighttime and early morning fog, especially during spring and fall. There are 4 types of fronts that appear on the surface analysis. Cold fronts, denoted by blue triangles, are typically associated with convective weather and precipitation near frontal boundaries. Squall lines and high wind shear are also commonly associated with cold fronts. Warm fronts are denoted by red half circles. Warm fronts are most typically associated with stratiform clouds and steady precipitation. Occluded fronts are denoted by purple alternating half circle and triangle shapes. Occluded fronts are typically associated with precipitation and possible embedded thunderstorms. Finally, stationary fronts are denoted by alternating blue triangles and red half circles. Stationary fronts are often associated with precipitation near the frontal boundary. This brings us to our next set of interpretation questions. Please read through the questions and write down your answers. Let's go over the answers. Question 6. Is there a pressure system in your flight route area? The answer is yes. There is a high pressure system. Question 7. Is there a front in your flight route area? The answer is no, there is not. Now let's continue with surface prognostic charts. There are 6 types of surface prognostic charts: current analysis, 12-hour, 24-hour, 36-hour, 48-hour, and 60-hour forecasts. These products show forecasted fronts, pressure systems, precipitation, and thunderstorms. The chart legend breaks down weather types into 5 categories, each with 2 probabilities. If a weather type is listed as chance, this implies there is a 30 to 60% probability of that weather type occurring. If a weather type is listed as likely, there is a greater than 60% probability of that weather type occurring. This brings us to our next set of interpretation questions. Please read through the questions and write down your answers. Let's go over the answers. Question 8. Which hour forecast did you access? The answer is the 24-hour forecast. Question 9. Is there a pressure system forecasted in the area of your flight route? The answer is no. Question 10. Is there a front forecasted in the area of your flight route? The answer is no. Question 11. Is there precipitation forecasted in your flight route area? The answer is yes, there is a chance of rain. And question 12. What is the probability of that precipitation? The answer is a 30 to 60% probability of precipitation. Now let's move on to infrared satellite. This product is issued every 15 minutes and provides pilots with information on cloud top temperature. This information assists pilots in determining relative cloud heights over a given location. The looped images also show cloud movement. Lighter colors indicate cooler temperatures and range from -70 to -40 degrees Celsius. These are mostly associated with high altitude clouds. Darker clouds indicate warmer temperatures and range from -40 to +10 degrees Celsius. These are associated with lower altitude clouds. Black indicates very warm temperatures, such as that of the Earth's surface, and therefore indicate little to no cloud is present. However, fog may still be present because the temperature of fog is nearly the same as the temperature of the ground, so fog would not be invisible on the infrared image. Areas of black range from +10 to +30 degrees Celsius. This brings us to our next set of interpretation questions. Please read through the questions and write down your answers. Now let's go over the answers. Question 13. Are there clouds near your route of flight? The answer is yes, there are clouds nearby. Question 14. Are there clouds approaching your route of flight? The answer is yes, there are also clouds approaching your route of flight. Question 15. What gray shade is the color of the activity, or the clouds, in your flight route area? The answer is that there are darker clouds colored in the area. Let's continue now to radar. Radar is issued every 4 to 11 minutes and provides current precipitation and activity in the area. Radar is measured in decibels. Fewer than 1 to 10 decibels is associated with noise and is considered no precipitation. 15 to 30 decibels is associated with light precipitation. 30 to 40 decibels is associated with moderate precipitation. 40 to 50 decibels is associated with heavy precipitation. Anything over 50 decibels is associated with extreme precipitation. This brings us to our next set of interpretation questions. Please read through the questions and write down your answers. Now let's go over the answers. Question 16. Is there precipitation currently on your route of flight? The answer is no. Question 17. Is there precipitation approaching your route of flight? The answer is yes, precipitation does appear to be approaching. Question 18. What is the decibels for the most severe precipitation near your route of flight? The answer is 40 to 45 decibels. That completes the big picture section. Now we'll move on to hazards. The hazard section is comprised of convective SIGMETs and G-AIRMETs. We'll start with convective SIGMETs. Convective SIGMETs are produced every hour at 55 minutes past the hour. The information is valid for 2 hours. Convective SIGMETs report widespread thunderstorms, severe thunderstorms, embedded thunderstorms, and squall lines. Convective SIGMETs are enclosed by red lines and provide a current and 2-hour forecast of thunderstorms. Convective outlooks are enclosed by orange lines and provide an additional 4-hour forecast beyond the end of the SIGMET. Wind-like barbs are also present on convective SIGMETs to indicate the speed and direction of individual storm cell movement. This brings us to our next set of interpretation questions. Please read through the questions and write down your answers. Let's go over the answers. Question 19. Does your route of flight take you through or close to a convective SIGMET? The answer is no. Question 20. Is there a convective outlook valid around your flight route? The answer is no. Question 21. Is there cell movement toward your flight route? The answer is no. Let's continue to G-AIRMETs. There are 4 primary types of G-AIRMET reports: Tango, which is turbulence; Sierra, which is ceiling and visibility; ice, which is icing; and freezing level. G-AIRMETs are issued every 6 hours. They provide an 18-hour forecast in 3-hour increments of the weather. When looking at a G-AIRMET Tango, it is important to pay attention to the rectangular boxes on the weather product. The bottom number in the box indicates where turbulence begins in hundreds of feet mean sea level, and the top number indicates where turbulence ends, also in hundreds of feet mean sea level. The color of the box indicates whether it is indicating high turbulence, for example, 18,000 feet mean sea level or above, low turbulence, for example, below 18,000 feet, service winds greater than 30 knots, or low-level wind shear. This brings us to our next set of interpretation questions. Please read through the questions and write down your answers. Let's go over the answers. Question 22. Is there activity in your area? If there is, what type of turbulence is present? What is the top turbulence layer? What is the bottom turbulence layer? And is any strong surface wind or low-level wind shear present? The answer is no, there is not any activity in our area. When looking at a G-AIRMET ice, it is important to pay attention to the rectangular boxes on the weather product. The bottom number in the box indicated the altitude or range of altitudes where icing begins, i.e., the range of altitudes where the freezing level begins, and at the top number indicates the altitude where the icing ends. Both values are again in hundreds of feet mean sea level. This brings us to our next set of interpretation questions. Please read through the questions and write down your answers. Let's go over the answers. Question 23. Is there icing at your flight altitude? The answer is no. Question 24. What altitude or range of altitudes does the icing start? The answer is 6,000 feet mean sea level. And question 25. Where does the icing end? The answer is 14,000 feet mean sea level. When looking at a G-AIRMET freezing level, it is important to pay attention to the lines and rectangular label boxes. If it is a solid line with oblique lines protruding from the top, then the freezing level is at the altitude stated in the box in hundreds of feet mean sea level. A jagged line indicates the surface temperature is below freezing. This brings us to our next set of interpretation questions. Please read through the questions and write down your answers. Let's go over the answers. Question 26. Is there activity in your area? The answer is yes. If there is, what is the freezing level? The answer is 8,000 feet mean sea level. Is it below or above the flight level? The answer is above. That brings us to G-AIRMET Sierra. Areas of G-AIRMET Sierra that are enclosed by a purple shape are areas where only instrument flight rule operations should be conducted. This is because either visibility is below 3 statute miles or the ceiling is less than 1,000 feet. Areas of G-AIRMET Sierra that are enclosed by a pink shape are areas where mountain obscuration occurs. This brings us to our next set of interpretation questions. Please read through the questions and write down your answers. Let's go over the answers. Question 27. Is there activity in your area? If there is, what type of activity is present? The answer is that there is no activity in the area. You have now completed the hazard section. Let's continue to visibility. The visibility section will discuss METARs and TAFs. Let's start with METARs. METARs are available in 2 forms, coded and decoded. Routine METARs are issued every hour, typically between 50 and 55 minutes past the hour. Special METARs may be issued when there is significant improvement or deterioration of the weather conditions. METARs provide a snapshot of the current weather at an airport. Because of their limited range, it is important to check METARs at multiple airports. You should check METARs at your departure airport, en route checkpoints, and your destination. Coded METARs chunk information into 10 sections of abbreviated text. Section 1 tells you the airport identifier. Section 2 tells you the date and time in Zulu. Section 3 tells you if the METAR was an automated report or a corrected report. Section 4 tells you the direction of the wind and its speed in knots. Section 5 tells you the visibility in statute miles. Section 6 tells you the cloud coverage, aka the sky condition. Section 7 states the temperature in Celsius. Section 8 states the dew point in Celsius. Section 9 tells you the altimeter setting in inches of mercury. Finally, Section 10 lists any additional remarks. Decoded METARs chunk the information in the same 10 sections. However, instead of writing the information in an abbreviated format, decoded METARs write out all the information. This brings us to our next set of interpretation questions. Please read through the questions on your departure airport and write down your answers. Let's go over the answers. Question 28. What is the wind speed and direction for your departure airport? The answer is 7 knots at 30 degrees from the north by northeast. Question 29. What is the visibility for your departure airport? The answer is 9 statute miles. Question 30. What is the ceiling for your departure airport? The answer is 6,000 feet above ground level. Question 31. What is the cloud coverage for your departure airport? The answer is overcast at 6,000 feet above ground level. This brings us to our next set of interpretation questions. Please read through the questions on your en route airport and write down your answers. Let's go over the answers. Question 32. What is the wind speed and direction for your en route airport? The answer is 12 knots at 350 degrees from the north by northwest. Question 33. What is the visibility for your en route airport? The answer is 10 statute miles or more. Question 33. What is the ceiling for your en route airport? The answer is 4,600 feet above ground level. And question 35. What is the cloud coverage or sky condition for your en route airport? The answer is overcast at 4,600 feet above ground level. This brings us to our next set of interpretation questions. Please read through the questions on your destination airport and write down your answers. Let's go over the answers. Question 36. What is the wind speed and direction for your destination airport? The answer is 12 knots at 360 degrees from the north. Question 37. What is the visibility for your destination airport? The answer is 10 statute miles or more. Question 38. What is the ceiling for your destination airport? The answer is 4,000 feet above ground level. And question 39. What is the cloud coverage for your destination airport? The answer is broken at 4,000 feet above ground level. You have now completed the METAR section. Let's continue now to the TAF section. Now that we've looked at each individual weather product, it is important to go back and take a holistic view at the weather information we've gained from all the weather products. This will allow us to ascertain what weather we might encounter in flight, the possible implications of that weather on your flight, and what can be done to mitigate the risk. TAFs do have a couple of extra features that are not found on METARs. Tempo groups provide information on temporary conditions for an allotted time. From groups provide information for rapid changes in weather over a period less than an hour. Weather conditions appear to be worsening. This can be seen in at least 2 of the products we've reviewed. The first forecast for the low-level significant weather chart shows MVFR conditions at our destination airport around your estimated arrival time. You can also see IFR conditions present just north of the destination airport. When you look at the next low-level significant weather chart, the areas of MVFR and IFR conditions have spread, and your destination airport is now within the red enclosed area with IFR conditions. Radar is also showing movement toward the flight area. When we look back through our notes, 2 weather phenomena stand out as potentially hazardous to this flight: precipitation and low cloud ceilings. The risk for precipitation can be seen in surface prognostic charts. Although the area around the departure is clear, the destination airport is located in a light green shaded area. This indicates a 30 to 60% probability of precipitation. Radar also shows regions of moderate precipitation moving towards the flight area. 3 of the weather products that gave us clues about cloud ceilings are satellite, the low-level significant weather chart, and METARs. The darker clouds on the satellite images indicate the cloud should be lower in altitude. The low-level significant weather chart shows MVFR conditions at 18 Zulu, putting the cloud ceiling somewhere between 1,000 and 3,000 feet at that time. The chart also shows IFR conditions at 06 Zulu, with a cloud ceiling below 1,000 feet. Finally, the METARs at our time of pre-flight show the ceiling lower from 6,000 feet to 4,000 feet as you approach the destination airport. With weather conditions worsening and cloud ceilings decreasing, it may be prudent to take steps to mitigate the risks associated with this flight. The best solutions to mitigate the risks are moving up your time of departure in order to avoid worsening conditions, or delaying the flight until hazardous weather has passed. This brings us to the conclusion of this course. We have now gone over the flight scenario, interpreted different weather products that gave us big picture information, hazardous weather information, and visibility information. We have also looked at the implications of information from these products on our flight, and we have determined ways to mitigate those risks. If you would like to go through another practice scenario, check out Preflight Weather Training, KAEL to KDTL, Weather Product Interpretation and Flight Implications.